Hi, welcome back. I'm Naren, and in this video, we will check out the basics of machine learning. So, we will try to find the basics like where we will use ML, what it is, and how we can use it. So, we will start with one of the demo for machine learning, which is the hand gesture, and we will look at the details about the demo before we go through the demo. So I'm trying to demo this on my laptop, a Windows laptop, and I have a Visual Studio Code, which is an IDE, and I'm trying to use it to run the demo code, which is in Python language. So you can install Visual Studio Code from the website, and you also need the Python. So I have installed the Python on my machine for Windows, and I also need a Python extension for Visual Studio Code that I have installed, and we need some more Python libraries that is needed to run the demo. And there is a website called PyPI which hosts a lot of publicly available Python libraries. We try to install some of the libraries from this website using a pip tool. So we can, when I installed Python, pip tool was available, so I can install any publicly available library which is hosted in pypi.org using pip install and the name of the library, and the tool will get the library from that website onto my machine and installs it. So I have installed 4 libraries: NumPy, OpenCV MediaPipe, and TensorFlow. So if I just run these commands, it will automatically pull in these libraries from that website and installs it on my laptop. And our demo uses these libraries. The first one, the NumPy library, is used for numerical n-dimensional arrays, which supports a lot of mathematical operations. OpenCV Python, it is a library for the computer vision, which was released in 2000 by Intel. And the MediaPipe library, it supports a lot of ML solutions, like the face detection, face mesh, iris, pose, a lot of these things. And one of the components in that MediaPipe is hands, and our demo uses this component from the MediaPipe library. And MediaPipe is a very fast library, so it can easily run on my laptop. And the TensorFlow is an ML framework library released by Google for open source in 2015. And I have downloaded the demo code from the Tech with One website, and you can also get it from the above link, which is a zip file, and you have to unzip to get some of the ML models and also the Python main code that will invoke this demo. So now let's try to run the demo on my laptop and see how it works. So we will try the demo now. I have downloaded the demo code from techwithone.com, which has all the details about the demo, and also it has a link here to download the project code here, which is a zip file. And once you download and unzip it, it will create these information. Like text with one hand gesture detection Python code is the main code, and there are couple of files and a directory. This MP hand gesture directory is the ML model, which has the saved model, which is the main model, proto buffer file, and variables and assets directory. And note that gesture names has all the list of the gestures that will be mapped by the model. And text with one, if you invoke this Python file, it will, in my case I'm running that Python file in my Visual Studio Code, and if I run it, this code, anyway, this is importing these libraries using the hands from the media pipe, and it is loading this ML model, that is the directory name MP hand gesture, and using the gesture names, that file that I showed, which has all the predefined gestures with the text names, that text names is used as the label when it identifies that gesture. And it will just use the Cloud Vision API to capture from the webcam, and it will read the frame and use the media pipe to process it to find a result, and have these find out the landmarks for the hand and draw them, and use the model that we loaded to predict a gesture based on the land. And we just get the class names from that file for this location of the prediction, and we write that class name on top of the image. So if we run this, I'm trying to run that Python code. So it has invoked, it was trying to capture the image from my webcam. So if I show the hand gestures to this webcam, it will try to read that image and try to capture the landmarks, and then based on the landmarks it will try to identify the gesture, which is a predefined 10 gestures, and it will apply the label on top of it based on the file that we have, and show that text at the top of the image. So this, it is identifying, see, it is identifying all the landmarks of my hand, and it is also finding it out that it is a thumbs up, so it is showing the text thumbs up at the top. So for this one, it is identifying as thumbs down, or this is a piece, this is a rock, this is a live long, this is okay, this is a fist, and yeah, this is like a call me, or maybe this is a smile. So this is the demo of the code, and to quit we need to press Q. That's how the code is, the demo code. If I press Q, the it will stop capturing the image. So this is the demo of our hand gesture. Let's look at some of the libraries that is used by the demo that we saw and how it worked behind the scene. So one library that the demo uses is OpenCV. It's a real-time computer vision library originally developed by Intel and open sourced in 2000, and it captures the image from the webcam in our demo, and it also writes the gesture label on top of the image and renders it when we change our gesture, and it displays. the same gesture with the text on top of it. This library also has ML support, and I don't think the much of it is used in this step. So another library is MediaType. Many ML solutions are supported by this library, like the gesture, face object detection, the motion tracking and all. And it's also used by Google in products like Google Lens, Photos, Gmail, Cloud Vision API, Google Home, Google Nest Cam, which is a security camera. And it is developed by Google and open sourced in year 2019. And in our demo, this library is used for hand and finger tracking and also to identify the hand landmarks. So where is ML in all this? So we have an image of the hand and we are trying to convert that into these landmarks. So here ML is playing its part. And also by using these landmarks, we are also converting that into a hand gesture. So there also we are using the ML to find out the gesture and map. So in the real time when we are running the demo, our code is getting image as an input and a module is trying to identify a hand and the landmarks in the hand and converting that into a gesture. And the output is showing the landmarks and a gesture label overlaid on. And the module in real time is having a capability where it is taking any hand image and is trying to predict the gesture. So in our demo case, we have a limited set of gestures, 10 in total, which are okay, peace, thumbs up, thumbs down, call me, stop, rock, live long, fist, and smile. So the module is trying to find out whether okay gesture exists in the given image with some accuracy. So similarly it is trying for each of these gestures, trying to find a score like a probability, how probable the given image has this gesture. With the scores for each of the gesture, the module picks one with maximum score, that means with maximum probability that the image has that gesture. And this module which is doing this work uses some data model and some library on top of that for predicting the outcome. And this prediction is known as inference in ML. And the library that we use to predict that is part of the TensorFlow. And TensorFlow is the open source library from Google for machine learning. And also we will, in later slides, we will also see this library is not just the TensorFlow framework, but something else also. And the module uses some data model, which is the ML model, which we will look a bit in detail in the next slides. So the module that the demo is using has two things: one, an ML model, and also some TensorFlow framework to how to use that model to predict the outcomes. And what is this model? So it is built in this case for a particular use case. So there is no generic model. So in our demo, we are using a model which is built for hand gesture, and it is built using TensorFlow framework. And when we say we build model, that is known as the training phase of ML. And we train a model for a particular use case, in this case, hand gesture using the TensorFlow. And a model represents mathematical relationship between the elements of the data that an ML system uses to make predictions. So as part of the training, the model somehow is representing that knowledge given as part of data to the training phase. So it is using that information to predict whenever a new information is given to the system. So let's look at the basics. So we have some historic data that we use to build a model using some machine learning algorithms. So this portion is called as model training. So this is an offline step where we build a model before we deploy the model for real-time use case. Once we build that model for a particular use case like hands gesture in this demo, we use that model in real time to predict things. Like in our demo, we are using the model to run our program where it will get a new data, which is the new hand gesture captured from the webcam, and the model tries to predict what is the gesture based on the information the model has acquired during the model's training, which was an offline process. In our demo, there was nothing related to training. We already had a model built, so we are just using that model with the new data to predict the gestures. Let's look at some of the examples of machine learning. Let's say you want to predict the house price in some real estate market. Or let's say you have a photo and you want to check whether it has a cat, or say dog, or both. Or in finance, you want to detect fraudulent transactions, or you want to play the game Go, or even the chess. In March 2016, there was a match between in the Go game. There was a match between Google's AlphaGo program versus Lee Sedol, who is a champion in Go game, and it was a 5-game match for 1 million prize. And during that match, AlphaGo has won this 5-game match with 4-1, winning 4 games against Lee Sedol. And that AlphaGo indicates one type of the ML, which is reinforcement learning. So that used this category of ML training, where the predictions results in getting a reward or penalty for the ML model as part of the training. So whereas in case of trying to build something for detecting fraudulent transactions, we use another category of ML called unsupervised learning, where you will have a lot of data, but you may not be having the answers for that data. You just want to categorize the data into different clusters. So a technique called clustering is used in unsupervised learning. So this is a visual representation of unsupervised learning, where you might have a lot of these data with, say, blue, pink, yellow color, but without any definitive answers for these data points. But with unsupervised learning, in some way you can try to group these things, and later on you can label them depending on manual inspection. And the third one is supervised learning, in case of, say, predict future house price or whether photo contains cat. In case of predicting future house price, what we do is you will have a lot of data with the characteristics of houses in the past and what their prices are. Maybe the data will have the location information, the size of the house, and related things are how old the house is. And you will also have the current market price at that time, like the historical data. And you will use that data with the correct answers. Correct answers will be the what was the price of that house at that time with those characteristics. And you will use that to train the model. And the output that you want to predict is a numerical value in such kind of example. So we normally use a regression model. That is one type of the supervised learning. Whenever we want, whatever we want to predict is a numerical value. In case of photo, there is no numerical value as an output, but it is more like you want to categorize these inputs. So in this case, whether it has a cat or not. So that uses another type of supervised learning called classification model. So we looked at the categories: supervised learning, unsupervised learning, and reinforcement learning. There is also something called semi-supervised learning, which is kind of a combination of these two. And what is training? So while training a model, we will have a lot of data which is specific to the problem that we are solving. And data may be in the form of text, video, image, speech, and more. And as part of the training, we feed the data into the model and the ML algorithms that will use the data to build and train the model. And when it finishes the training, we will end up with a model which can be used in real time for any application to read a new kind of data which may be similar to the data that we used for training. And now the model will try to predict the outcome, so which is known as inference. Let's look at an example for weather prediction app. So we want to have the data about the location and the characteristics of that location, and also let's say a date, the location lat long, what was the temperature, humidity, cloud coverage, wind direction, atmospheric pressure, and also the data about how much rainfall happened at that moment. So this one row of data, we consider that as one example in the data set that we use for training the ML models. Since in the weather app, we are targeting to find out how much rainfall can happen, this output of the target value is considered as label in the machine learning dataset. And rest of the characteristics of the dataset is known as features. And when we have a label, that means when the data we are using has the output value as well labeled, then this is known as the labeled data. In some cases, we may not have the output, the target predicting the value. So we will have only features. So that is called as unlabeled data. And whenever we want to gather data for machine learning, the main two characteristics that we expect from the data set is it should be very large and highly diverse so that it can cover most of the areas that the new data can fall. So in case of supervised learning, you need labeled data to train the models. In case of unsupervised learning, you won't be having any labels for your data set. You just want to categorize your input data. So you will be working on the unlabeled data in case of unsupervised learning. So when you are training, you will give your data set to your model as part of the training. So for each labeled example, model will try to predict the output. And after predicting, it tries to compare it with what is the label, the output, which is part of the test set. So it will compare what is the prediction versus what is the actual one. And based on that, it will fine tune and update the model so that it can generate almost similar output. So this is part of the training. And in the training also, we will have some part of the data set used as for the evaluation when you complete the training. Then we can use that to evaluate how it is doing and predicting the values so that we can compare that with the already existing output, which is part of the data set. So this is called the evaluation of the model. There is also something called problem framing in ML. That is to check whether ML is the right approach for your problem, and also how you can frame your problem for the ML use case. Let's say we are talking about the weather app. So while doing the problem framing, you will consider these 5 things. So first is goal. So in case of weather app, maybe you can specify goal as calculate precipitation in 6-hour increments for a geographic location. And maybe use case. When it comes to use case, you should always ask whether your non-ML kind of solution, whether it is optimized. Because without optimizing that, you should not enter into the ML space. Because you can, one is, there may be a lot of cost to build and maintain the ML solution. So you need to cross-check that with the non-ML solution. And also, you need an optimized non-ML solution to even check the quality of your ML solution, whether it is better. And you need a lot of data to go for the ML solution. It should be abundant, consistent, reliable, trusted, available, correct, and representative. And the data set, the features of the data set that you can identify should have a predictive power for the output. And there should also be actions that you can take based on the predictions, otherwise your ML solution is useless. And now let's look at what is that model that we are talking about, which is used, which is built as part of the training, and also which is used during the real-time use case of the ML model to predict the outcomes for the specific problem. So when you are training, we know that there is a training data, and using that we are building an ML model. And note that to build the ML model, we will use some ML algorithm. Normally there will be standard ML algorithms. We pick based on the problem, our understanding of the problem. We pick some of the implementations of some of the algorithms, and we use those algorithms to build an ML model based on the training data. And the algorithm is like a pattern recognition of the data, which is trying to learn from the data, and it's like fitting into that data set. And some of these machine learning algorithms are listed here, like for supervised category of the ML. There are so many algorithms. For regression, there is linear polynomial, decision tree, random forest. For classification, KNN, naive Bayes, SVM. Or for clustering, SVD, K-means, a priori, FP growth. So all these are the standard ML algorithms. So based on your problem definition and the use case, you will pick the implementation of some of these algorithms and train your data using that algorithm, which outputs an ML model. And the ML algorithms, that is what we have seen in the previous slide, is normally a classical algorithm, which is a non-deep. So here, most of the algorithms dependent on human intervention to learn. Like it needs a structural data, and also human experts has to determine the features in the data to help as part of the training. There are other kinds of algorithms which comes under neural networks, and these algorithms are based on the brain like logical structures, and those algorithms will have an input layer, one or more hidden layers, and an output layer. And in neural network algorithms, there are three major types: artificial neural networks, convolution neural networks, recurrent neural networks. And when we are talking about these neural network machine learning algorithms with minimum 2 hidden layers, we call it as deep learning. So deep learning is a subset of the machine learning algorithms. So machine learning will have the machine learning algorithm which is used to train any data set into a model, and it uses the different machine learning algorithms. And among those machine learning algorithms, some of them are based on the neural networks, and that too with minimum 2 hidden layers, and those kind of algorithms are known as deep learning algorithms. And for these neural network algorithms, there is an open source library which gives support for these machine learning algorithms, and it has Python interface to use with the TensorFlow, which is the Google's ML framework library. So you can see a lot of Keras names, and because you will be using those libraries when you are using the ML. And again, coming back to the modeling. So we know that when, as part of the training phase, you will be using an ML algorithm, and that ML algorithm will output a model. And this model represents rules, numbers, and algorithm specific data structures which can be used to make the predictions in the real time scenario. And note that model, since it is an output of the training phase, output of an ML algorithm, normally you will have some data as the output. But in this case, ML model not only will have some data, it will also have some procedure. It's like a program for using this data for predictions. So model is not just pure data, it will also have some kind of code where it can take decisions and predict based on the data in the model. So when you have a model, and when you use it, in this case, in our case for the demo, maybe we have a model we are using, and it is not only using the data, it is also using some kind of program also which is part of the data in the model. And on top of it, it is using the TensorFlow framework libraries. So along with TensorFlow library, it is also using some procedure inside the model and the data to predict the outcome. So what is this procedure, and how we are storing that procedure in the model itself? Let's first look at what is protobuf. So protobuf is used by Google. Like whenever you have something kind of a data output in your code, and you want to transmit the data over wire on the network to some other server, you need to serialize the data so that you can transfer the data with that structural information on the other side of the network and get it back in the original form. So Google uses the protobuf. It's kind of a, let's say, SE struct, some data structures, and also it's a library which knows how to convert any data structures into serialized data to send it over the network and get it back. So Google uses protobuf to store the structured data and efficiently serialize and transport it over the network. So TensorFlow also uses protobuf to save the model. So when you use this TensorFlow to train a model, like you are having some data set to train and you're running some ML algorithms using the TensorFlow, and TensorFlow finally outputs using the ML algorithm some data model. So that data model that you save is using the protobuf to represent that information. So it has some definitions, standard definitions like graph, graph def. You can imagine like a struct, C++ struct or some class information of C++, if you're not familiar with protobuf. And some mathematical ops, like apart from some graph information in the model, this model will also have some function information which can be operated on top of the graph. So it may be specific to some of these neural network graphs. And some operations will be represented, and some basic functionalities of the code, like maybe if else kind of control structure, such things can also be converted into this function definition using autograph, which is part of the TensorFlow, into a TensorFlow graph. So through these things, there is support not only to represent data in the data model, but also some functionalities and operations. It may be like summing all the inputs from different nodes in case of neural networks, or multiplying the weights with the input signals in a neural network. So it also supports some procedure kind of code along with the model that can be represented within the model and used later while predicting. Apart from protobuf, there is also TF-Lite format which can be outputted, and it is used for mobile or edge devices like. And we have a format called saved model, and in our model also, in our demo also, we have used a saved model as the protobuf, which contains information in the form of metagraph def. And in our demo case, the model is represented as a saved model. This is the format that the protobuf structural information. And with this file name .pb, pb is used for binary protocol buffer files. And so this is the model, which is actually the TensorFlow program. As I said, it is data plus some kind of procedure used. And the data disk can also have assets, which can include files used by the TensorFlow graph, which is represented by the model. It can also have some variables directory that is, I think, mainly used for training checkpoints and all if you are continuing the training later. So in our demo case for the hand gesture recognition code, I had this directory, and under this directory we had the MP hand gesture was the model that directory represented the ML model demo case, which had a saved model as discussed, which is a protobuffer, and also it had Keras metadata protobuffer along with the assets and variables directory. So this is our ML model, how it looks on the disk. So we have seen so much of machine learning, how it can mimic the human behavior. But there are also non-ML cases where you can mimic the human behavior. One example is chatbots, which is purely rules-based system. So if it is just rules-based, we can just build a chatbot without using the ML, but still it can mimic the human behavior to some extent. Also, you can have an NLP use case without the ML. So there are some cases where you are trying to mimic the human behavior without using ML also. So with using ML and also without using ML, how we can try to mimic these human behavior and enable the machines. That is the artificial intelligence topic, the area. So artificial intelligence is the outer layer, the machine learning. So machine learning is a subset of the artificial intelligence. Even though we might see major use cases of machine learning in the artificial intelligence and major use cases of deep learning in the machine learning, but it's AI, ML and DL are not same. So this is a subset of this is a subset of AI. So now let's come back to our demo and look at the models. So our MediaPipe hands that we used for the demo, it kind of, I think, used 3 different models, like palm detection model. This is like given a full image which is captured from our webcam, it should try to find out the oriented hand bounding box. It should detect the hand from the image. And another model, given this bounding box, which is detected by the previous model, the hand landmark model should try to find out the high fidelity 3D hand key points. And this model was trained using some around 30k real world images which are manually annotated. And I think it also had another hand gesture model, because given this 3D hand landmark of the hand with those key points, it should be able to find out whether it is a thumbs up, thumbs down, or it needs to map it or predict the gesture. So I guess it might be using the CNN convoluted neural networks for that. So to do a recap of what ML is, it's more about computers learning from data. It's an intersection of computer science and statistics. So you will end up looking at a lot of statistics based things in these ML algorithms. And it is kind of like regular coding where we implement some algorithms to do some specific tasks. But when you come to ML, as a practitioner, you don't do any explicit programming for that specific task. You will be spending more time in using existing ML algorithms, finding out which one to use, and collecting data, training the specific models using your data to find or come up with a model as an output, and use that model again using the TensorFlow and related ML algorithms and frameworks. So that's why we say that it is algorithms for specific tasks without explicit programming. And as a part of the ML, it tries to recognize patterns in data as part of the training and use that to make predictions for the new data. So if you find this useful, please like, subscribe and share, and thank you for watching.